All right, all right. And the last part. Please pause the video and copy this graph on your paper. And I'm not going to sit here and wait because obviously you guys can pause the video. All right, so this problem I'm going to be focusing on domain and range. Now, let's not forget what domain and range is. Domain is our set of inputs, also known as our x. What x's are used in this function? Range is a set of outputs or our y's. All right. Now remember, yes, I understand we haven't talked about this. We're not going to talk about this. It's actually a cubic function. You guys are going to see this in algebra 2. But it doesn't matter because you understand what a function is. A function is just a relation where we got some inputs and some outputs, right? So all these points represent the function, okay? Now the question wants to know is, hey, what is my domain and what is my range? Well, remember, all they want to know is what are the x's and y's that are used on this graph. So if you look at this, can you sit here and list all these points? Yes, it'll take you forever. So what we can do is we can actually project these graphs onto the x and y axis. Why? Because that's going to tell us the x and y's that are used. So if I'm looking for my domain, I know domain is x, right? Well, look, if I'm focusing on this graph and I'm looking at the x, right, my domain, what is the leftmost point that I have? Well, the leftmost point is this one. And notice how when I project it up, there's actually an open dot. So what does this mean? This means that this point started at -4, -5, and it's an open dot. Right? So I need to keep that in mind. So this point here, -4, is an open dot because it's an open dot on the actual graph. Now, again, I'm worried about domain. Domain is the inputs, the x's, right? So look, if I go to the right, notice how, look, all these points project onto the x-axis, right? If I continue, but what is the furthest I go? Well, if you look at it, it's this point. Notice how once I hit x is 6, it doesn't go anything further. There's no x equals 7, right? So when I project this down into the x-axis, notice how this is a solid line. I'm sorry, a solid dot. Why? Because this point 6, 7 was part of the graph, so I have to project it down. And look, what are the x's that are used? The x's is everything that's in between those two. So we're right on equality here. Well, x has to be between -4. Again, this is saying x is greater than -4 because it's everything to the right, but it has to be less than 6 because it's heading to the left. So x has to be less than or equal to 6. Again, notice how I took my points in terms of left and right and I projected them onto the x-axis because that's what domain is. Now let's look at the range. Well, what is range? Range is the y's. We're looking for our y coordinates and everything that's used. So when I look at the y's, I'm looking at the y-axis. And I'm looking at the highest and lowest point because that's going to tell me all the y's that are used. So for me to do that, I project it onto the y-axis. Right now, look at here. This y, this point here is -4, -5. The y has a value of -5. And because it's an open dot, I have to keep it open over here because, again, that's signifying that it's an endpoint, but it's not equal to it. When I look at the other point, again, and keeping the same mentality, all these points are projecting onto the y-axis. Again, no matter what y you choose, it's always being used. But if we continue along, what is the highest point here? This point here is 7. When I project onto the y-axis, that is a solid point because it's a solid dot. And look, again, we're looking for the range. That means that all these points between -5 and 7 are used to make this blue line or this function. So what are the ranges then? Well, the range means that it's the -5 is the lowest. Again, because it's an open dot, it's not equal to it, so y has to be greater than. And what's the highest y can be? Well, the highest it can be is 7. Right? And again, if you want to write these using words, you can also say domain is all real numbers greater than -4 and less than or equal to 6. I know it's a little bit to write, but you could also see it like this on the test. You can see it both in inequalities and you can see it as sentence. So again, this is the same thing. These two are the same. It's all real numbers. Because again, notice how this graph, this function goes from anywhere from -4 to +6. The points exist anywhere there. That is why it's all real numbers. Remember, these are just coordinate points. So it's all real numbers greater than -4, greater than -4, x is greater than -4, and compound less than or equal to 6. Less than or equal to 6. What about the range? Well, the range is the same thing. All real numbers greater than -5 and less than or equal to 7. Again, we're talking about the points that are used. What are the numbers? So the slowest point range is the y's. What's the smallest y here? The smallest y is -5. And again, notice how to know dot, y has to be greater than -5. Greater than -5. Y has to be less than or equal to 7. Less than or equal to 7. Why? Because this is the highest. All right? So again, be ready for some of these problems. Make sure to understand the graph and the function. All right? Moving on. All right. Take a few seconds, pause the video, and write down this problem on your end. So again, write it or pause the video so you have time to write it down. I'm going to start talking about it. In this problem here, Johnny is a softball and baseball coach. He needs to buy baseballs and softball for the upcoming season. Each softball costs $4 and each baseball costs $2.50. If he has $150 to spend on these items, write an inequality that shows the amount of each he can afford. They don't want us to solve here, first of all. They want us to write an inequality that shows that scenario, right? So the first thing we need to be able to do, and if you guys remember this from chapter 2 when we did it together, is we need to be able to write things in terms of words, right? So what is Johnny doing here? Well, we're trying to buy some stuff, right? So we're trying to get, or we know that the number of baseballs, and we're going back to cost, right? So the cost of baseballs and cost of softballs has to be less than or equal to 150. So notice how I'm looking at it in portions, right? And I was going to write this down, but I'll just do it here. So we have some very special things going on. Here we're talking about Johnny buying baseballs and softballs. And what do we know? Well, we know that he has to spend money on baseballs and he has to spend money on softballs. And we also know that he has less than or equal to $150, or he has $150 to spend, right? Now, once we have this, and you guys remember chapter 2, we have to write down our variables. So, what are the variables that we're talking about? Yes, we're given some important information. We're given the cost of each softball is $4. And yes, the baseballs are $250. And he has $150 to spend. Right? So notice how here we're not bringing those numbers in, and we can't just yet. We first have to identify what are the variables. So in this case, I'm going to let X be the number of baseballs. Again, notice how here this was the cost. And it makes sense, right? Cost and cost must be equal to cost, right? Which is 150. Money plus money is money. So X is the number of baseballs. Y is going to be the number of softballs. Now I can actually sit here and make my equation. How do we find the cost of baseballs? Well, the cost of baseballs is $2.50 times the number of baseballs that I'm buying. Do I know how many baseballs I'm buying? No. But I do know that the variable X represents the number of baseballs. So it's $2.50 times X. I want to put the time sign here just so you see it there. So the cost of the baseballs I actually get by multiplying $2.50 times the number of baseballs. And if you guys remember, it's just a fancy word of saying plus. Why? Because I'm combining those two costs. How to find the cost of a softball? Well, it's $4 per ball times the number of softballs that I'm buying. So here it's 4y. Now, what do we know here? Well, we know that he has up to 150 to spend, right? Can he spend 151? No. Can he spend 150? Yes. Can he spend 149? Yes. So that is how here we have to be very careful on our verbiage or our inequality. So in this case, this less than or equal to, I'm actually going to sit here and write the inequality. Give me 1 second. I can't even find it now. Oh my goodness. Oh, symbols. There we go. Less than or equal to. Right? It's less than or equal to because the cost of the baseballs and softballs combined must be less than or equal to $150 that he has to spend. There it is. So when I write this fancy, I get 2.5x plus 4y is less than or equal to 150. And again, that gives a scenario. The number of baseballs times each baseball is 250. The number of softballs times $4 each softball. And I know that everything combined must be less than or equal to 150 because that is what I have to spend. All right. So again, in this problem, they want us to write inequality. So again, notice how I'm not sitting here writing the equation first. You have to be able to read carefully.